Hello dear friends, welcome to another video of the Never Do Through the GUI what you can do through the CLI channel. I am Vangelis and today we will be watching Web API benchmarking .NET 6 vs Rust actix-web. So this is the third video that I am making regarding Web API benchmarking. I already tested PHP with Laravel and Node.js with Express, and today we will check how the the latest .NET 6 performs vs Rust. So let me show you. The setup is the usual setup. I have a controller here which returns 1000 users for this case, and this is our endpoint, and we just get the users and we return them. I bumped up a little bit the data to 1000 users instead of 100 users because both .NET and Rust are quite fast, and I wanted to stress things a little more, so I bumped up the data. Plus we will also bump up the requests. The Rust project is the same if you want to check it out. This is the endpoint that we are hitting here, and we are getting the users, and the users is the same 1000 users. So we have a similar setup, as you can understand. So let's get into the benchmarking. These are the endpoints that we will be hitting. They are not working currently. So let's start with our .NET API. We will say .NET run release. Let's check if it works. It works. We get our users. So next step is to benchmark. Let me get the command. We will be using the Apache benchmark again, this tool, but I'm bumping up the requests, as I said, to 500,000, and we are executing 1020 concurrent requests. Still, the keep alive option is not used. I don't use it because I want to stress the server as much as possible and also check the response of the server in regards to the request, and I want the whole life cycle of this thing and not just the code. So let's start hitting the API. Let us give it some time to perform the requests. The overall feeling that I get is that it is quite fast, I would say, .NET, which I would admit that it is a little bit surprising to me. I would expect it to be slower, but it is quite fast. Okay, we got our results for this API. Let's kill it. Let's come here and make sure that it does not work. And let's go and fire up the Rust API. So we will cargo run release. And we get our data. And just to make sure that it is 1000 users, you can see that the last ID is 1000. So we have the same amount of data. And now we are ready to hit this endpoint too. So let's fire it. And let's prepare for the outcome. You can make your bets now on which tool will win if you want. Okay, Rust is done, so let's start our comparison. Server software, Kestrel, server hostname, port, okay, length, concurrency level the same, time taken for tests. This is the first thing that it's interesting to us. So the .NET needed 47 approximately seconds to perform the requests, and Rust needed 39.5 seconds. All the requests completed without any failure, which is good. In PHP we had failures. Requests per second, it's 10,668 requests per second, and for Rust it is 12,669. So we are about 2,000 requests per second more for Rust, which is impressive in my mind. 2,000 requests more per second. Time per request, 95 milliseconds for .NET, 80 milliseconds for Rust, and this reading is also similar, as you can see, 94 milliseconds, 79 milliseconds. The transfer rate is 875 I always get confused in English with the numbers. 1, 2, 3, but here in Rust we are in the million, as you can see, 1.2 million gigabytes per second, whereas for the .NET we are at 875,000 kilobytes per second. So it is a substantial difference here too. The connection times, I have not looked into these. I cannot interpret these. I don't know what they are. And the percentage of the requests served within a certain time in milliseconds. In the last video I said that I don't really understand this, but I looked into it, and this is how this is interpreted. So for example, here we have 50% 94 milliseconds, and here we have 50% 81 milliseconds. So what this means is that for this amount of time, 50% of our requests will complete. So 50% of the requests need 81 milliseconds or less for Rust. In .NET, 50% of the requests needed 94 milliseconds or less to complete. So this is how this is interpreted, and we reach the 100%, which says that this is the longest request too, which was 1.2 seconds, and for this amount of time, for 1.2 seconds, all our requests will complete because they need this amount of time or less. This is why we have a 100% here. And for Rust, the longest request was 3.1 seconds, which is amazing to me. And this is the 100%, so it means that for this amount of time, all the requests will complete because they need this amount of time or less. I don't know how exactly this is such a big number, because as you can see, the time distribution for Rust is quite stable. You see that we are in the 80s for all the requests up to 99%. So maybe this number was a very small amount of requests. I can't interpret this, but the crux of the issue is that, as you can see here, for 88 milliseconds, 99% of the requests will complete, which is very good. Whereas in .NET, the 99% needs 150 milliseconds, which is almost the double of this. Almost. So, for 99% of the time, .NET needs almost twice the amount of time in order to complete the request, according to these stats. So the winner, to wrap it up, the winner is Rust again, but indeed .NET performs very well, and I was surprised. Again, I say I was surprised because I would expect it to be less efficient because it runs on the .NET runtime, but it performs quite well, so kudos to the engineers of Microsoft and of .NET, because it's open source now. But for me, there's no chance that I would pick .NET instead of Rust for creating a web service, because as you can see, it is a lot more efficient. Plus, the safety that Rust provides is not delivered by the .NET, nor is it delivered by any other tool, the memory safety that it guarantees. So this was the information that I wanted to share. I hope it will be useful to you. Thank you for watching and have a great day.